In this section, we will talk about exceptions in Reason. Exceptions are useful for signaling and handling exceptional conditions. In other words, they are useful for capturing all kinds of errors, and at the same time, they enable us to handle these errors. Compared to other programming languages, raising and handling exceptions in Reason is very fast. Let's define our first exception. We declared the finished exception. Exceptions in Reason are declared using the exception keyword. Since we declared our finished exception, we can now use it. The compiler is telling us that a value finished has a type of exception. Exceptions are constructors of a predefined variant exn. And these constructors can have arguments like any other constructor. However, they are a little bit special because we can define new exceptions dynamically. This means, unlike regular constructors, we can define them at any time, just as we defined the finished exception in our example. We also have predefined exceptions which we don't need to declare in advance, as we will see later. Moreover, exceptions cannot be polymorphic. We must fix the type at the beginning. So, let's pass a string argument to our custom exception. As you can see, our finished exception now expects a string as an argument. So, when we use our exception, we need to pass it a string as well. This way, we can make our exceptions more readable. Once we have declared an exception, we can raise it. Raising an exception means that we tell the compiler that we have an exception and the compiler should stop everything and print the exception. Let's take a look. To signal our exception, we use the raise keyword to wrap our exception. When we do that, the compiler answers that it found the finished exception. It's telling us that it stopped all computations because of this exception. Let's take a look at how this works in another example. As you can see, when an exception is raised, all computations are immediately stopped. Only the exception is returned. In our example, we first raised the finished exception, and then we wanted to return a string learn reason. However, when we run our code, we haven't got any string back. We only got back our exception, because the execution of our program immediately stopped when it encountered the exception. It stopped before it can evaluate our string. Let's take a look at a more complex example. In one of the previous sections, we created a function that maps two lists. We have the map2 function, which expects another function and two lists as arguments. In the function's body, we use pattern matching to extract the element from the first and second list at once and pass them to the functional argument and call the map2 function recursively with the passed function and with the rest of the list 1 and list 2. Finally, the map2 function returns a single transformed list as the result. However, when the past two list arguments are of a different length, we will raise an exception instead. As a result, the execution of our program will stop and we will return this exception. Let's take a look. We passed the add function and two lists of a different length to our map2 function. And we got back an exception instead of a new list. And this exception is telling us that lists have different length. This happened because the map2 function expects two lists arguments of same length. However, we passed two lists of a different length. And when this happened, our function raised an exception, returned this exception, and stopped the execution of our program. In other words, we encountered a runtime error. You might noticed that we haven't declared the invalid argument exception in advance, and that's because this exception is already predefined in Reason. So we know how to raise an exception. Let's take a look at how to handle it. We defined the getTitle function, which expects a string and checks if this string is equal to the title identifier. If they are equal, our function will return the learnReason string. Otherwise, we will raise the NotFound exception. Let's capture this exception. We can capture an exception in Reason using the try keyword. We can do that by wrapping our function call using this keyword. And then we will use pattern matching to get our result. In our example, we called the getTitle function and passed it the learnHaskell string. Our function raised an exception because the passed string is not equal to the title identifier. Then we matched this exception and returned the Don'tLearnReason string. As you can see, we didn't need to declare the NotFound exception in advance because this exception is already predefined in Reason. Let's take a look at another example. We defined the multiply function, which expects a list of integers and recursively multiplies its elements. However, when we encounter the number 0 in the list, we don't want to continue the evaluation of the rest of the list because we know that the final result will be 0. And that's why we added this pattern matching logic, which will check if the element has a value of 0. And if this is the case, we will return 0. However, when we encounter 0 in this example, the evaluation will continue and all the following recursive calls will be executed. So we will be doing a lot of unnecessary multiplications by 0, which is pretty inefficient. In a case of thousands or millions elements in the list, this would mean a lot of unnecessary recursive calls. And this is where the exception comes into play, because it can save us a lot of computation time. So let's rewrite this example using an exception. We declared the exception called done. Our definition of the internal multiply function is similar to the previous example. The difference is that when it encounters a list element of value 0, it will raise our done exception. And when this happens, the execution of our program will immediately stop and all the recursive calls will be thrown away. And we will use pattern matching to compute the result, which will be 0. And we will get this result without unnecessary recursive calls. As you can see, we can take an advantage of exceptions to make our code more efficient. In Reason, many runtime errors are caught as exceptions. These errors are different from type errors, which are caught at compile time, because runtime errors don't crash the program. They are wrapped in an exception which we can handle. We've already seen examples of runtime errors in the previous sections. Let's take a look at some of them again. We used the built-in function to convert a string to an integer. And we got back an exception since this string cannot be a valid integer because it's composed of letters. We defined the divide function, which expects 2 arguments and returns their division. Then we passed it 2 integer arguments, and as a result we try to divide by 0. And we got back an exception telling us that this isn't possible. We defined an array of 4 integers and we tried to access its 5th element using an index number 4. And we got an exception, since we tried to access an element which doesn't exist, since the length of an array is its length minus 1. And this error cannot be caught by the compiler during compilation time, since the compiler cannot predict if the expression that we are using as an index will eventually evaluate into a valid index of the array or not. So we get back the runtime error wrapped into an exception that we can capture and handle. So let's handle this invalid argument exception. As you can see, we wrapped our array access logic inside the try keyword and used pattern matching to handle the invalid argument exception and return 5 as a result.